Hello, this is an example of using a normal distribution to make a probability calculation or to find the percentage of some group that meets some criteria. Here's the question. It says, in a study involving over 20,000 infants, the head circumference had a mean of 33.9 centimeters and a standard deviation of 1.3 centimeters. All right, let's stop there for just a moment and let's write this down before we keep going here. So I'll use the Greek letter mu for mean, 33.9 centimeters. Standard deviation, it says, is there's mean. Standard deviation 1.3 centimeters. Okay, assuming the distribution is normal, that's pretty important that it's a normal distribution, otherwise we can't do this calculation. What percentage of newborns had head circumference greater than 35.0 centimeters? All right, now before we go any further, a little bit of background. Whenever a baby is born, the hospital staff will take several different measurements like height and weight and so forth, and they also will measure head circumference. Here's a picture of a newborn baby getting his or her head circumference measured. This baby's head circumference looks like about 31 centimeters. So this baby's head is a little bit below average because the mean, we're told, according to this study of 20,000 infants, the mean is 33.9 centimeters. All right, so out of these 20,000 infants, if you were to make a histogram of all of their head circumferences, it would look like a normal distribution. Most babies' heads would be around 33.9 centimeters, but plus or minus 3 standard deviations, which would encompass 99.7% of all the babies. All right, so let's just make a quick sketch. So this is step one. Step one is to make a picture and do a quick estimate of the answer. All right, and so the mean, once again, is 33.9. Let me write it sideways so I can fit the numbers in better. All right, so go up 1 standard deviation. That would bring us to 35.2 centimeters. Plus another 1.3 standard deviations would be 36.5. Is that right? Yeah, and then plus another 1.3 would be 37.8. All right, now going down, 32.9 minus 1.3 is 32.6, minus 1.3 is 31.3, minus 1.3 is 30.0. Okay, so this picture tells us, according to the 68-95-99.7 rule, 68% of the newborns had a head circumference between 32.6 and 35.2 centimeters. 95% of the newborns had a head circumference between 31.3 and 36.5 centimeters. And the 99.7, almost all the babies had a head circumference between 30.0 and 37.8. Now, in this question, we're asked to find the percentage of newborns with a circumference greater than 35 centimeters. So let's find that on the curve here. 35.2 is exactly 1 standard deviation above the mean. So 35.0 is a little bit less than 1 standard deviation, right about there. We're asked to find the percentage of newborns with a head circumference greater than 35. So let's shade in the region that represents all the babies whose head circumference is greater than 35 centimeters. Now, for a quick estimate, I can see right away it's less than 50% of the babies, because less than 50% of the area of the whole thing. But we can refine our guess a little bit. According to the 68-95-9.7 rule, if I just round this to 1 standard deviation real quick, then I would have 68% of the babies have a head circumference within 1 standard deviation, leaving you with 16% below average, below 1 standard deviation, 16% above 1 standard deviation. And so I could say roughly 16% of the babies, that's a really rough estimate. Actually, a little bit more than 60% because it's a little bit less, the cutoff is a little bit less than 1 standard deviation. So let's say maybe 17, 18%. That's a rough guess. It's always good to have a rough estimate in mind. So if you make some mistake, you can catch that mistake by knowing what the estimate is to begin with. Okay, so now that we have a picture, we have an idea of what's going on, and we have a rough estimate. Step 2 is to compute the z-scores. Okay, so the z-score formula is x minus the mean divided by standard deviation. So in this case, x is the number we're interested in. X is a 35. So it's 35.0 minus the mean, which was right here, 33.9, divided by the standard deviation, which is 1.3. All right, so let's get a calculator out. Let's do this calculation. Here's a calculator. So 35 minus 33.9 is 1.1 divided by 1.3. So 1.1 tells you that 35 centimeters is 1.1 centimeters above the mean. But what is that in terms of standard deviation? So divide by 1.3. Let's get our calculator back. Okay, here it is. So 1.1 divided by 1.3 is 0.846. Let's just round that to 0.85. When you're using a table, usually the table only has these scores up to 2 digits after the decimal point, so let's just round it to 2 digits. So roughly speaking, this means that if there's a baby with a head circumference of 35.0 centimeters, that baby's z-score would be 0.85, meaning 0.85 standard deviation above the mean. All right, now that we have the z-score, it's a standardized score for 35 centimeters. Now, step 3 is you go to the table. And we're going to look up 0.85 on the table. There's a link to this table, and let's get the table up here. Here it is. Okay, so here's the standard normal probabilities table. I want to find 0.85. The first page has negative z-score, so we don't want the first page. Let's go to the second page. The second page has the positive z-scores. Now, notice according to this picture right here, once you look up the z-score, the number in the table tells you the area to the left. Now, in this particular question, we're interested in the area to the right. So we'll have to subtract from 1, but we'll do that later. Let's just take care of looking up the number first. So my z-score was 0.85. And so first, you look up the first digit on the left side. The first digit after the point. So 0.8 is right there. And then the second digit, the 5, you look across the top. So 01, 02, 03, here's 05. So 0.85, you can see where those two match up. Right there, 0.8023. So that's the number from the table. So back to our main screen here, 0.8023. So let's draw a picture of what we just figured out. So this area, the area to the left, is oh, I forgot. Just a second here. Let me look it up again. It was 0.8023. All right. So 0.8023. Roughly 80% of newborns have a head circumference less than 35 centimeters. So remember that the total area of the whole curve adds up to 1. So then just subtract from 1 to get the area on the right. And so 1.0000 minus 0.8023 You can use a calculator for this, or just do it by hand. It's not too hard to do by hand. There, all those become 9s. And so you have 9 minus 2, 9 minus 0, 9 minus 1. So 0.1977 is the answer. Convert to a percentage, move decimal point 2 places, so 19.77%. So 19.77% of newborns have a head circumference greater than 35 centimeters, which is pretty close to what we estimated from the beginning. I was thinking 17 or 18%, a little bit more than 16%, so 90% turns out to be the precise answer. All right, now one drawback of using a table is the z-score is only rounded off to 2 digits. A more precise z-score, if we go back to our calculator, was 0.846. So this number was rounded up a little tiny bit. So the true percentage is going to be a little bit different, but it's going to be close enough for doing our work. And that's it.